Welcome to my projectbazaar.com. Let me discuss about the process DBR-MAC, a depth-based routing aware MAC protocol for data collection in underwater acoustic sensor networks. Let me discuss about the abstract of the project. Underwater networks consist of a variable number of sensors and vehicles that are deployed to perform collaborative monitoring tasks over a given area. Underwater acoustic networks are very unique and can be deployed for commercial and military applications. The research of UASNs attracts increasing attention in recent years. Depth-based routing protocol is working with MAC protocol, in which protocol all packets of data are forwarded from deep to shallow nodes along the direction towards the locations of sync node. Here load imbalance occurred due to directional of packet transmission. Key nodes transmitted most load packets compared with the other shallow nodes. Existing MAC protocols does not consider the key nodes priority of accessing channel in collision domain. In order to improve the throughput, energy consumption and delay are performed with DBR based MAC protocol. A MAC address is a unique serial number. Once a MAC address has been assigned to a particular network interface, that device should be uniquely identifiable amongst all the other network devices in the world. This guarantees that each device in a network will have a different MAC addresses. In depth-based transmission protocol, consider depth information, angle information and one-hop neighboring nodes and allowed key nodes to higher priority. Here proposed cross-layer scheme and its transmission based on directional forwarding used to forward the packets from source to floating sync. Routing algorithm determine the specific choice of route. Each router has a priori knowledge only of networks attached to it directly. A routing protocol shares this information first among immediate neighbors and then throughout the network. This way routers gain knowledge of the topology of the network. Let me discuss about the flow diagram for our process. Initially, the system model has been designed. In this system model, data transmission direction and rank map management are performed. In data transmission direction, DBR-MAC protocol provides the accurate estimation of transmission delay between nodes. Each node can count the neighbor's hop for transmission. In data transmission stage, all the underwater sensor node must transmit packets to floating sync node. First, the overwater monitoring platform converts the solar energy into electric power, stores it to power the whole cell cluster node. Power and data are transferred on the mutual channel between the monitoring platform and the underwater sensor. That channel is made up of overwater inductive coupler, closed steel string. The underwater inductive coupler in a DBR-MAC node is able to construct the rank map, which includes the propagation delays between the node and its one-hop neighbors and between one and two hop neighbors. Time of arrival is a travel time of a radio signal from a single transmitter to a remote single receiver. Compared to the TDOA technique, time of arrival uses the absolute time of arrival at a certain base station, and in the data transmission, the time difference between departing from one and arriving at the other station has been analyzed. And in the first, initially all nodes are sends the RTS packet to neighboring nodes. If that neighboring nodes reply with the CTS packets, that is the RTS packet sends nodes are receive the CTS packets, then it receives the acknowledgement packets, that is ACK packet. If didn't receive CTS packet, then again the data transmission process will be performed. And in the objective function, maximal transmission range and maximal propagation delay of one hop will be performed. And in depth-based transmission scheduling, calculates the transmission and reception times for all the messages required for successful transmission to the destination node. If any of these communication would collide with any neighboring or local reception, a node backs off its communication and reattempts the transmission session after a back-off period. This is performed in the adaptive depth-based back-off algorithm. And finally, the performance has been analyzed. In this analyzed performance, we calculated the throughput of DBR-MAC protocol in the first hop of the data transmission. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder like and run for executing this process. Here we perform the underwater sensor communication. Here initially the nodes are deployed and the sinks are placed at the outermost, that is surface of the underwater, and here every node has been performed for shortest path communication based on the depth-based routing algorithm with MAC protocol. This process will execute for some time for perform every nodes in the underwater environment. After performing the routing process, we analyze the graph, and this is the throughput graph, and by varying the packet generation rate, here we deploy 20 nodes. Here we compare the DBR-MAC algorithm with existing algorithm, and this is the energy consumption graph by varying the packet generation rate. Here we deploy the 20 nodes and compare with existing methodology, and this is the throughput graph. Here we deploy the 40 nodes by varying the packet generation rate, and also we compare our proposed method with existing algorithm DBR-MAC protocol with MFAMA, DOTS and SFMA algorithm. And here energy consumption graph for 40 nodes by varying the packet generation rate, and also we compare the proposed with existing algorithm, and this is the delay. Here the packet transmission delay has been analyzed for 20 nodes by varying the packet generation rate, and here so we analyze the transmission delay for 40 nodes deployment by varying the packet generation rate, and here we analyze the fairness index by varying the packet generation rate for our existing and our proposed system. So far we deploy the underwater sensor nodes and performing routing algorithm for underwater sensor nodes. Thank you.